Now we'll see isometric projection sheet problem. Problem number 2. Figure shows front view and left hand side view of an object. Draw its isometric view using natural scale. Also show all dimensions. Now here in this problem, two views, that is front view and left hand side view of object are given to you, and ask that you have to draw a isometric view. So our step number one is find out the overall dimension. So if you see front view, length dimension is 30 plus 30 plus 30, so 90 is the length dimension. Then height dimension, so if you start from this base point, so radius is 35, so first dimension is 35 up to this, then 50, and from this 2 times 25 plus 25, so 135 is the height dimension. Then width dimension, so width dimension you will get in a side view, so R35 means diameter of this is the width, so 35 plus 35, 70 is the width dimension. So after getting these three dimensions, you have to construct a three isometric planes. Now these three isometric planes, as again origin is given to the lower left corner, so you have to construct this front view on right isometric plane. So this right isometric plane is the plane for front view. Then on this right isometric plane, we have to mark a length dimension and a height dimension. So height dimension is 135. So from this, let us mark a 135 height dimension, and width dimension is 70. So this is the width dimension. So mark the width dimension as a 70. So this is 70 dimension, and height dimension is 135. So more height, and these are the right isometric plane and the left isometric plane to construct a front view and left hand side view. So now you study this problem. Here origin is given here, but this origin will be here if you consider a side view, left hand side view. So this will be the position of origin. Then and you first concentrate on this front view and side view. In side view, this base two plates are there having a half round, and the thickness of each plate is 30 mm. So two plates is there, and again in that two plate there is a pocket, and the bottom portion of this two plate is having a radius, or you can say half round, and in that half round you have the two holes of diameter 35 diameter. So in this plate there is hole, in this plate there is hole. Then after that this pocket is there, and the top portion. Now if you see the two views simultaneously, so the above portion of these two half plates is again a plate at the center of this vertical plate at the middle of these two plates which joins the bottom two plates, and that top plate, central plate, is having inclined surface. So one straight surface and inclined surface. So these details you have to show on the isometric view, in isometric view. So we'll start with this. First we'll do, so the width dimension we'll consider first. This again a typical problem. Here you have to mark the center point. Suppose from this point the height is 35, or total height is 35 plus this 50, 85. So at vertical from this base at 85 height you have to draw a line. So up to this dimension is 85. So draw a line. So this is the line at 85, and above this 85, what is there? The vertical surface is there. So that vertical surface is again from this point, the we are coming down 50-50, so 50 below and 50 below. Again, there is a line, this line, and on after this line we have this half circle. So let us mark a midpoint of this also, and center line. So center line. Then in this we have to draw a half circle. So what is this dimension is 35, 35 and 35. So we draw again above also 35, and we'll draw a rhombus. So this is the rhombus. So bigger angle and midpoint of this, bigger angle and midpoint of this side. Again this bigger angle and midpoint of this bigger angle and midpoint of this. Okay. Then you consider this as a center to draw the half circle with the radius. So let us draw a half circle like this, half circle. Then this as new center. You draw this arc with this as a center. Okay. Then vertical line, and in this you have a hole, one more hole is there. So for that, this is the center point, and the hole diameter is given 35. So again we will construct a rhombus of side 35, that means say 17.5 to this side, 17.5 to this side. So like this is the rhombus of 35 side length. Again in that rhombus you draw a bigger angle and midpoint line, bigger angle and midpoint line, bigger angle and this midpoint line, bigger angle and this midpoint line. Here you have to draw a full circle. So for this full circle, what we'll do, we'll take this as a center and a radius. Again these two as a center and radius. Again intersection of these two lines as a center and a radius, and this has a new center and a radius. So this is the inner circle. So only one part of this we had completed. So then this horizontal thickness of this plate is 30 mm given, and this 30 mm it is after this 85 we have a full length line. So we'll complete here like this, and after this, after 30 we have the gap, and so this inner is this dimension is given 10 from this. So this dimension is also given here 10 mm. So from this top we'll draw a 10 mm line, and on this 10 mm line, first 30 mm line, 30 mm, second 30 mm, and this one is the, you can say, third. Okay, so third 30 mm like this, and so this is not there, this is there, and this gap. Okay, so here in these two we have to draw a symmetric arc. So first center of this arc is you shift, draw a line, inclined line, and you have to shift this center of this arc by 30 mm. So let us say this has a new center, and with this as center with same radius you draw another arc. You draw with this as a radius with this as new center, you draw a arc. So you draw this arc. Then what is the center of another? From these two, you have to draw a tangent line. So this is a tangent line. Again, you shift this center again by 30 mm. So this is new center, and you have now same arc again with same radius. So let us draw a arc like this, and again you shift a center 30. This is a new point, and from this center again you draw a arc. But for this arc you have to draw a tangent line. So to this arc you have to draw a line. Okay. Then inner circle. So inner for this inner you have centers. This center again you draw a faint construction line. So this center you have to shift. You have to shift here by 60 mm. So total this 30 plus 30 60 mm, and you take this as a new center. Again draw a, here you draw a similar arcs. Similar arcs you have to draw here with shifting the centers. With shifting the centers. Then what else? What else is remaining? So here we have on this both side. So this total is 70 plus middle one is 20. So that means 20 70 minus 20 50 is remaining. So 25 from this side and 25 from this side. So from this side you draw a 25 mm. From this side you draw a 25 mm and get this point and draw a vertical of height 25. So here the height is given 25. So draw a vertical of 25. So here is 25. Then after that incline line, but from back side you will find that the line is up to the height. So the total for this total height. So here you draw and you have a total height. Sorry. So consider this as symmetric. Then from this point you have a length of 50. So from this point you draw a 50 isometric line of 50. Then the thickness of this is 20. So 20 mm again you draw to this side 20 mm again this side 20 mm. So 50, and you have to join this. So these are the faint construction lines, so need not to draw these lines, but this is the final drawing of our object, where the now we have to give dimension to this isometric view. So whatever the dimensions are given in front view, same dimensions you have to give here in this view. So 30, 30, and 30. This dimension is given. Then from center point, from this center point to the to this height, the dimension is given. So this is the center point. So this dimension is given 50. So 50 dimension, and then 20 dimension. So this dimension is given 20. So let us give this 20 dimension. Then this height dimension, here the height dimension, this height is given 25, and another height dimension is again given here from this to this. So if you draw a top of this like this dimension is also 25. Then radius dimension of circle. So outside radius is given r35. So let us take this outside r35, and inner circle diameter is given. So let us write inner circle diameter as 535. So 535, 50. Then this tail dimension. So this tail dimension is, you can write here. This is the tail dimension 10. Okay. Then what is remaining? 50 dimension. 50 dimension. So here you can write a 50 dimension like this. 50, 25, 10, then 35. All dimensions we have written. One more line is remaining here. So from similar to this, here is also one line, which is you have to draw this line. So here the portion is free. Now our next task is compare that isometric view to these two orthographic views, whether our isometric is correct or not. So now for front view, if you see what we will observe, these two plates. So these two plates with a gap of 30 and two holes. So two dotted lines for these two holes. It is correct. Then this line. So this line is for this surface. It is also correct. Then top surface. So incline, slant line, incline and straight portion. So this, as per that isometric view, our front view is correct. Okay. Then this dotted line. So this dotted line is for this 10 mm line, which is below. So 10 mm line, and dotted line is indicated for that. Then now from this side, if you see, so this rectangle, this portion T-like portion, and the bottom one are these half circles and inside inner circle. Okay, so this completes our isometric view. So give all dimensions, whatever the dimensions given in orthographic projection, same dimension, same method of dimensioning you have to follow while giving the dimension to isometric view. Here, this again, why I had selected this problem for a sheet, because this problem consists of inclining non-isometric line, then arc, then a circle projection, isometric projection of circle, and half circle, and one non-isometric surface or non-isometric line. So this completes our entire solution of isometric projection. So all of you should draw this with natural dimension. Natural dimension is same as that of the orthographic dimensions. Okay, we'll stop here.